I'm Dr. Buragohain, Assistant Professor, Department of Zoology, Master Forest. Today I'm going to present on the similar topic, transport of carbon dioxide in the bloodstream matters. So, as you know, we are taking the oxygen and you are releasing the carbon dioxide. So, if the carbon dioxide is not released in the body, it will become toxic in the cell and it will damage the whole cell or whole the body. Ultimately, the people will die or the animal will die. So, we have to release the carbon dioxide as soon as it is formed in the body. So, how this carbon dioxide is transported in the body, or how it is releasing from the body to the environment. So, there is a three way this carbon dioxide are released: the plasma from 7% and the bicarbonate from 70%. The majority of the percentage of carbon dioxide is transported in the bicarbonate form. It is the ACO, aminohemoglobin form. As you know that hemoglobin transport that oxygen, but as you know that hemoglobin is the component of two parts. There is the heme part and the globin part. And globin is the amino acid part. There is the protein part. That in heme part the iron is there, so it binds with the iron with the oxygen for the transportation. But the globin part, there is the amino acids. Amino acids bind with the carbon dioxide to form the carboaminohemoglobin form. So, as a negative charge going out from the RBC, so these are reaction carbon dioxide plus water in the form of carbonic anhydrase enzyme that is present in the RBC. So, with the help of this enzyme, the reaction becomes faster, more than 1000 times. So, it becomes the carbonic acids H2CO3. It's an unstable product and it breaks down to H positive ACO negative. And this, the bicarbonate form, that goes out to the lungs. So, if the negative charge going out from the RBC, so there will be some, the positive of the cell will be increasing. Then ultimately, there will be difference between the positive charge and negative charge, and the RBC will break down and will burst. So, to counterbalance that one, to ACO3 negative, the chlorides go inside from the plasma to the RBC so that it becomes balanced. So, that phenomenon was discovered by the Hamburger. So, that phenomenon is known as Hamburger phenomenon. So, I can show you in the slide. Next slide, you see that this is the RBC. The carbon dioxide react with the H2O to form the carbonic anhydrase. This is carbonic anhydrase. This chloride go inside the RBC. So that phenomenon is also known as the Hamburger phenomenon. Also, it is also known as the chloride shift phenomenon. So next slide you can see. This is the I already explained this carboaminohemoglobin. So you see that 20 to 25%. You see the hemoglobin is two part, globin part the protein part and heme part the pigment part. The amino acids present in the globin part is the protein part and it binds the carbon dioxide the hemoglobins and from the carboaminohemoglobin is HBOCO3, CO2. And this is a compound that is formed that react with the hemoglobin. So, and the Helen effect. What is the Helen effect? So, generally these type of questions are generally asked in the exams. The combination of oxygen with the hemoglobin causes the hemoglobin to become a stronger acid. When the oxygen binds the hemoglobin, the blood becomes a strong acid. And as a result, the carbon dioxide is releasing from the blood. Now, this is known as the Helen effect. So, thank you for listening my presentation. Thank you.